Hello.
Oh, look at that. Look at that wonderful weather.
It is like 80 something degrees outside today. It's very
Oh,
nice out.
that's great. Oh, 80 degrees and everybody else is freezing up north. Yeah.
Oh yeah. Yeah, we were having some internet troubles at home this morning, so I took a nice trip outside.
Good. Very nice. Very nice. It's not I can't say it's 80 degrees here, but it's pleasant. It's the 60s. I'm sure it's 80s for Russ too. So yeah, looks like we got here's some more coming. Okay.
Hi, everybody.
Hello, everybody.
Hey, Bat.
Hey,
Hello.
hello. Looks like we got the crew here. Good. Um, I would like to start with Grady and I got some things to announce and ask questions about. I think some of you are aware that we're getting this CDK 17 at SRO that's being donated to us by John Downing, and it'll be a fabulous place for us. And we're configuring it so that we can do speckle. And the configuration I can pull up. I will pull it up in a minute and have some discussion. I'll pull up what it looks like if we use a 2.5 Barlow. But and it's a QHY 600, just like the 24. So it's got real. It's very parallel to what's being put together in Chile. Knock on wood, we hope the QHY can work for us. So after yesterday's conversation, that's not a certainty. But one of the things was that although we went to 2.5, it appears that there's not a 2.5 power mate for 2-inch format. It's the best is 2, or there's a 4. But Dave, I'm thinking that the 2 would give us about a 0.13 arc second per pixel scale, and
Right.
And is that acceptable?
I think so for what we're doing, and we can always run up there and change it later if we want to do something with higher resolution.
There's
So
a
I think-
4. A 4 would take us, to almost 0.7 or something.
Yeah, then we might not be able to plate solve. So, it's always a kind of a trade-off.
Well, and why would the plate solve be a problem? It would just bend, right?
Well, it's the size of the field, right? So if we go to 4x Barlow, then we have 0.07 arc seconds per pixel. And if we multiply that by the dimension, the resolution dimension of the camera, which is what, 9,000 by 7,000 or something.
Yeah.
What do we get in terms of square arc minutes? I don't have a calculator.
I think we can. Let me pull up the scaling on that. I'll get that. I should have brought it up before.
Well, I think 0.11 was 40 square arc minutes. So, and it goes like the square, of course. So
yeah,
if we go from 0.11 to 0.07, we lose a factor of 2. We're down to more or less 20 square arc minutes, which will give us about 40 or 50% probability of plate solving, which isn't good enough. So the question is whether you want to be able to reliably plate solve the field, which of course is really good because it makes everything simple in automation. If you can't plate solve the field, then it's much harder to fully automate the acquisition.
But also with a plate scale of 0.07, there isn't much else you can use it for.
You can't use it for anything else either, right? So I thought there was a 2.5x. I guess there's not a power mate that has the right aperture, huh? That's too bad.
it's a 1 1/4 for that. Grady was just on the phone with him, I think, this morning, right, Grady?
Sir, yes, sir.
Yeah. So,
I got a 2.5X Barlow Power Mate design, but not from that company, Teleview. It was from Siebert Optics.
No, no, those.
And it was about, yeah, it's a small outfit, a one-man job. Basically, he does all his own machining and orders good quality optics from I don't know where. And you know, he'll do custom designs, and he did a 2.5X Power Mate design for me. It was about $300.
In a
2 inch.
2-inch, in a 2-inch format. Well, that would be
Yeah.
the ideal, device. So if you want to donate that to the cause, that would be great, Rick.
Well, I'm not using it at the 22-inch very often, so yeah, I could probably throw it in there eventually.
Super. Well, eventually is kind of like now, right?
yeah.
Ah,
Yeah. Oh, yeah. We're
kind of
in a-
depends whether I want to use it at the 22-inch anymore or just
That's
rely
right.
on
You have to,
other telescopes.
you need to decide about whether
Yeah.
you want to donate it.
here's,
So-
am I sharing my screen? This
Yeah,
is
you are.
the field of
yes, sir.
view with a 2.5. I have not run it with the 2, or with the 4 either.
Oh, that's beautiful. huh?
Yeah, that's a huge, that's why I'm wondering if maybe we should we can let the discussion go. I'll go off and do the calculation with the 0.07 and see, just to confirm what the field of view is. But this is nice. I mean, it's such a huge sensor. With the 2.5, you can do all kinds of things with it. You can do speckle, or you can do photometry, or even I guess even you might even be able to do astrophotography as well, I guess.
Well, yeah. I mean, astrophotography would work really well with that magnification for galaxies. So it'd be a real great galaxy scope.
True. Let me, Grady, we have another question also we want to run by. I'm trying to remember what the other one was.
The filters, trying to get our arms around the filters.
Yeah. I think we're probably, everybody seemed to be happy with the idea of going with the Bader filters, the 6 filter Sloan set. And we're going to put and then obviously have to have a dark, but we were going to do a luminance, but rather than luminance, maybe a pro planet. And Dave, you suggested 2 different ones, and I wasn't entirely clear on what the difference is and which one we might choose, or if we need to have more than one.
Right. So there's 3 ProPlanet filters, as I recall. One is a long pass at 805 or 807 or something. The second one's a long pass at 750.
742, I think.
742, and
Something
the
like
third
that.
one is a band pass at it's like a IR band pass or something, right? Anyway,
like-
the one that I think the one that Rick and I would recommend is either the 807 or the 742.
And what does its band, what's it look
Okay.
like in terms of the
So,
notch? What's it?
A long pass is you pass everything beyond, redder than a certain wavelength. And band passes, you
Yeah.
cut it off at both ends.
Okay, so this is going to be cut off at 805 or 742?
No,
Right.
it starts there and goes redder.
It's- yeah,
It
gets
starts there.
redder.
Okay, that makes more sense. Okay, I didn't understand that. So that's really red.
It's really
Yeah, but
red.
it's-
It's like the Sloan Z, except a little bit on the blue end, a little further on the blue end.
And it worked really, really well. The 807 or whatever, it's 807, right? The 807 worked really well at GBO with the 290 sensor. I know this sensor doesn't have quite the red response
No, it
as
doesn't.
the 290. Nonetheless, it'll still be it's the right filter for the red dwarf studies.
Okay. But yeah, okay, I see. This is for the red dwarf settings. Okay.
And I'll
We're
let
getting
Rick
it. We're
pick-
getting a Y filter with the Sloans.
Yeah, because the Sloan set is so cheap, you might as well get it. I mean, that's an incredibly
Right.
good
Yeah.
price.
Yeah.
Right? So,
So, yeah,
No,
so we're gonna get
Y
a
and a
Y.
Z.
It sounds like it's a little redundant.
A Y and a Z, right?
Yeah, oh, yeah, the whole smear.
So,
Yeah.
so they're, yeah, the set, the 807 might be a little, feed a little more light than the Z filter, I think, but I'm not sure about that.
Okay.
yeah, then Rick,
Just
you may
my
want
rule.
to, you may want to pick the 742, right? I don't
Yeah,
know.
that kind of overlaps the Sloan I and Z together and sort of combines them.
Which is an excellent, I think that's going to be an excellent filter for red dwarf.
Yeah, I think it would be too. It'll be a better response for that camera.
Right.
How
The
cheap is
Wetter worked great for the 290, but it's got about twice the response out there in the 900 nanometer range
Mhm.
than the 600 does.
Yeah,
So
the 600 really falls off, yeah. Okay,
I was going to suggest one of those little transmission gratings also to do really low resolution spectra. The idea being, if there are some white dwarf, red dwarf combinations, you might be able to see both those signatures, even though the star is not resolved.
yeah,
Where did you
I
get
think that's
that?
a really interesting suggestion.
I don't know whether it would work, but
It's
you're
worth
we
a
interested to
try.
talking-
try it.
Are we talking the Tom Field ones? Or are we talking somebody else that manufactures these?
Yeah, I guess whoever you can get them from, the ones that have 100 or 200 lines per millimeter, they're not super high resolution, but they're, yeah, I think it's Tom Field that, the guy that did our spec.
Yeah,
Does that work
Keep-
with,
Keep in mind, these are all 50 millimeter square filters, so we got to,
Yeah, I don't know
They're not
whether they have,
that
One of
what's
those.
available is another problem. Yeah,
does it
Right.
work with high magnification? Sorry, Kelly.
No, go ahead. Sorry.
I don't know how much the spectra would be removed from the star itself. You know, it displaces the spectrum as the star becomes the zero order and the spectrum becomes the first order, and they're separated from each other, but I don't know by how much and whether it would land in the field or whether you'd have to have
Well,
a
what I'm
lot of
worried
difficulty
Yeah, what I'm
finding.
worried about is the magnification is so high that
Right.
the spectra will be spread over a huge number of pixels, and you may not, the read noise may dominate.
It could be.
So you have to, a calculation, I think, is required. I don't think it's going to work, to tell you the truth, but prove me wrong.
I thought of doing the same thing a few months ago with a 200 line filter. So I did some calculations also on a QHY, and that was without a Barlow at 2 meters focal length. And there it was already spread over a significant portion of the sensor. So
Yeah.
very unlikely that it would work.
It's too much.
Right.
Maybe a 100 millimeter or 100 lines per millimeter might be better, but even that might be too much.
Well, I was just gonna ask, Tom just arrived and see, I think I summoned you mentally because aren't you working on this flex spec thing that if that could be leveraged, they're talking right now to catch you up about trying to get some low resolution spectra of red white dwarf pairs. Is that in any state nearing ability to be used?
First off, sorry for being late. I've been gone and doing all kinds of fun stuff, but I think the answer to your question, Kelly, is that flex spec it's in use over in the Great Britain by Tony Rhoda over there. There's another one just about to be set in motion. I think Jerry Foote has one just about finished up, but the long story to be short on this is the fact that it's not going to actually be ready for general use until the rest of the software is written. So I would, if you need low resolution spectra, go with something like the Alpi if you want, or even Star Analyzer. You could probably use a Star Analyzer if you need something like 100 lines, or I think that they have a 200 line also, I think, Grady, but it's not a true like litho spectrograph. It's just a dispersion system and a little harder to use, but could be used.
Can these be operated remotely or robotically?
Yeah, once everything is all the software is finished, they'll be remotable. In fact, let's see, I think Tony Rada over there is put it on and he's done a little bit of remote stuff with it, but there's still some motor issues, so we're working on it.
So we have a Botter spectrograph. It's roughly 10,000 lines resolution. R equals 10,000. Sorry. And but that requires a separate optical switch, which we're not going to have on the 17, nor can we put it there because we won't have the swing through. So it really belongs on a larger scope, but I think let's not mix spectra right now with this thing we're trying to do. SRO is so easy for us to access. It's a kind of a 4 or 5 hour drive for me, and we can do kind of whatever we want with it later. Getting the filters and the Barlow correct for speckle is, I think, the big deal here. Right.
I agree. Yeah. Hey, I've got both calculations for 2 and 4 Barlow up here on the screen. I'll share
Great.
those. Okay. So obviously the red outer square is the 2 and the yellow is the 4. And the 4 comes out with a 0.18 degrees by 0.12 degrees. So
How many square arc minutes is that?
Square arc minutes. Let's see, 0.18 would be, what is it? So 11 arc minutes, is that right?
Yeah,
And by
10.8.
12.12 would be 7. Look, it sounds like 77.
That big. I made a big mistake somewhere in my estimate. Okay, so if that's true, well, 0.18, yeah, is
It's like 11,
Yeah.
right?
Yeah, that's correct. Then they'll both plate solve easily. So if you want the highest resolution you can get, go with the 4. If we want to get to the ultimate, the fraction limited resolution on the 17, then we should have the 4x Barlow, even in red.
Let me bring it back up again. Sorry.
My calculator batteries died, and I'm like totally lost without a working calculator. I can't.
Okay,
even-
here's let's see, the stats on the point of view, and the Dawes limit is 0.27.
Right.
It gives a focal ratio of 27.
So you see 0.27, 0.07 is about 4 pixels per Dawes limit, which is 4 or close to 5, which is exactly right for the highest resolution. That Dawes limit is at what wavelength, Pat?
I don't know. I don't think they give you that variable in this. It's a good question. Yeah. Good question. I don't know what this is, just an online calculator.
Probably V-band. So
Yeah, I would think so, yeah.
Yeah, so the Dawes limit is going to be a little bit bigger in red, which is where we usually work. And so so the 4x is perfect for diffraction limited speckle, if that's where we want to go. And it still plate solves, huh? That I find incredibly hard to believe, but okay.
Yeah, I'd certainly feel, since we're going to commit to this, is going to make a major change. I'd really enjoy your afterwards taking a calculation on it.
I'm actually going to
battery.
Right, I'll have to pick up a pencil and a piece of paper and actually multiply and divide. No, I'm good.
Okay.
No slide rule, Dave?
I have one in my backpack. Yeah, and I have an abacus here that's even better. So, okay, if that's correct, then I would love to try the 4x, because that's like the cat's meow. of speckle. We could do, 0.3 arc second stars on a 17-inch telescope, which would be phenomenal. That would be fun.
I've got a calculator thing, a spreadsheet, and it says that that'd be 11 pixels across the area disk, which is pretty high sampling. That's going to make every pixel dimmer than we've ever done before.
Well,
So
that's what you have to do to get to right. I mean, but you can always bin 2x2, even though binning, in a CMOS camera is kind of stupid because it actually doesn't do anything interesting.
But maybe
to
a
it.
3.
So-
Is there a 3 power?
No, unfortunately.
No,
And does speckle degrade with binning, or can it work just as well?
well, okay, so what happens if you bin is you have cut your resolution, say, by a factor of 2. So you get half as many pixels across the area disk, which means you'll have a resolution, an ultimate resolution when you bispectrum it, that'll be, half the resolution or twice the separation.
Okay.
Okay, so Leon says he reports that it's a V-band, right?
V-band, yeah.
And Rick tells me that it's, we have 11 pixels, with a 4X, we have 11 pixels across the area disk, which is too much. So I think we have the answer. We probably use Rick's 2.5X and he just donates it to the cause, right?
Yeah. That's
the right one. Yeah.
This sheet says 2.5. Barlow gives 6.9 pixels across the area disk, which is just about perfect. Yeah.
Yeah. So that really is the right gadget for this.
Well, that introduces a new problem in that we've got to design that optical train and the spacing and everything for the back focus and all. So we would need to know a lot about that, that 2.5 he's got in order to get. Eric Brackwell's going to work up the calculations for it and do it drawings.
A correctly made designed Barlow, the focal position doesn't change when you insert it. In other words, it's identical if you remove it, put the camera in, or if you take it out, put the Barlow in and put the camera in, you should be at the same focal location on the camera.
Well, that's good, but we have to worry about swing through. And so the
only thing we have to worry about is swing through, right?
Yeah. And so we need to know the dimensions at least, so pretty carefully.
Do you plan to do anything else with that telescope? Because at that field of view, you're pretty limited.
Lots of things we can do.
Is there a plan to put a rotator switch like you have on BASRO and use more than one camera?
No, there hasn't been a plan on that. I don't know if it,
because that just takes up more back focus then.
Takes up back focus and makes it mechanically. They work okay. I mean, geez, the Optec 4 works fine, the Perseus, but it just complicates it. I see Grady cogitating there. What are you thinking, Grady?
I'm just trying to keep up.
Oh.
One of the things we're doing with our spectrograph, not that it's applicable here, but is we're folding it over with a 90-degree.
Yeah.
It does introduce additional loss because you can't get 100% reflectivity off the mirror, but if it's got good coatings, then it's probably not too bad.
Yeah, that's what I've been thinking is probably if we had to, we'd go to that on the swing through, but
the trouble with diagonals is they often have bad optical aberrations, which aren't advertised. So
yeah,
I've measured a bunch of them and every one's been sort of horrible, to tell you the truth. So like a wave or two of astigmatism can be that bad.
Yeah. Well, in Leon's question, we plan to use it also for exoplanets. And, as long as you have a field of view that's big enough to capture comp stars, I think it's going to work.
That's what I was going to say. You won't have many good comp stars in that magnification. And for a spectroscopy, your spectra will move out of the image.
Well, let me raise a point here that I know comp stars are the way that you have to go if you want to be in compliance with AAVSO or whatever, but the right way to do it is completely different now. You should be using the Gaia catalog. So if you're not, you probably are getting kind of the wrong answer if you want an absolute magnitude. So anyway, there's always enough stars in the field of view. They just aren't approved by.
Oh, yeah.
They're just not
We almost never get approved stars in the field of view. Yeah.
Yeah. So, you have to rethink the whole issue of how you do that. Anyway, if you imagine you take an average, let's say we don't even care if they're variable or not. Over a transit period, how much is any one of the stars if you take an average of 100 stars? So, the right way to do it, the lowest noise way in every sense is to take as your comp star the average of all of the stars in the field of view. And if you've got SAO stars that are known not variable, and we know a lot about SAO stars, then just use those. So
yeah, we do that, and we also there's an algorithm that we use that identifies the star with the least variability over that transit, which is the set they ranks them, and so that allows you to select a handful that are fairly stable.
yeah, and you can do the calculation, but I can tell you that if you use only one comp star in the field, then you're going to add a bunch of noise to your photometry estimate because of the read noise and because of scintillation and so forth. So you have to really rethink this.
I'd love to have that dialogue with you and some of the people in Exoplanet Watch, because they and Calais knows, they're basically they devolved to one comp star in their automated approach, and it's like, doesn't make sense to me.
Well, I've had this conversation with two other professional astronomers, PhDs in astronomy, and I got nowhere. They really adhere to the dogma. They have almost like a religious attachment to the use of a single or two comps, it's actually single comp star, because it's always been done that way, and that's the way you do it. And anyway,
that's changing, though. I think most people use ensemble comps, and Exoplanet Watch is kind of a renegade for using the single comp method. Like, everyone sort of gives sharp intakes of breath when I mention that, and sometimes they don't even use a comp at all. I was putting that in chat. What they do is a fit. They do a quick fit to the light curve using the priors from the NASA archive, and they take the way that's the least noisy. So it could be a user selected comp, or it could be no comp. And at least 10 or 15% of the time, no comp wins.
Right.
For their quick fit, in which case they don't use a comp at all, which, like, you can imagine the sharper intakes of breath when I mentioned that.
Yeah. So I guess it's starting to change. Maybe we're starting to get a little bit smarter, but there is a lot of legacy stuff here that people have in their brains. Anyway,
at ExoClock, it analyzes the image, you click on your target star, and tells you to use every single comp as long as the SNR is similar or higher. With a small notice at the bottom, please check the star color first, because if you're observing low on the horizon, then those comps will get invalid. But they also encourage use as many as possible. Though
that makes more sense than what they're doing with Exoplanet Watch. That makes a lot of sense. Yeah.
Okay, well, that's not my battle.
Yeah. So
that's your battle.
Yeah.
But, there's always going to be plenty of stars in the field to actually do the proper measurement. It's only whether your fellow humans are going to, look askance at you when you do that. So it's not a problem it's not a technical problem at all. It's only the way that you manage the comparison.
Right. Well, I'm worried what Rick's saying that about the area disk and 11 pixels across. Is that going to foul things up?
Well, like I said, Rick's going to donate his 2.5 Barlow, or we'll have to find something that's in the right, range. Maybe we can have a custom one made is another possibility. Botter may have stuff on his shelf. They're really a good bunch of people. Johannes has taken over that company and he's doing a really good job. So, if we need a 2.5x Barlow, put in a 2 right now and we'll find a 2.5. And I'll drive it up there or send it by mail to Sam, and he can put it in for us.
Pat, if it would help, I could bring my rig down to your place and just see how it might fit together. Because
We don't have any of the components. All the stuff's up at SRO. Yeah. All the stuff's at SRO.
Make a little field trip up there.
If you could, can you take a picture of it just so we can see it, and we'll.
Sure.
Yeah, take a picture of it and see what and whoever the contact was that you bought it from.
Yeah. Okay.
Yeah, do that, and we'll chase it down.
Yeah, we'll order you a replacement, but we probably don't have time to get it, from the company right now.
Right.
Yeah, he's pretty slow on delivery.
Yeah, but are the optics good on it?
I think so. I don't have any way to tell.
Yeah.
But he claims that they're comparable with Teleview, and the same design. I don't know, he seems to care about making good stuff.
Okay. Yeah, send us a picture and the contact information for him, and we'll see if he can get us the necessary specs for Eric to design it.
Okay.
Okay. Cool. Thanks. The only other question. Oh, does anybody have an opinion about FOI filter wheels? And the reason I raised the question is you can't get any service if something goes wrong. And so I ran that question by Eric, and Eric says, no, it's, well, he understands the problem for sure. And he says there's no other really super filter wheels out there. But I don't know if he's really studied it. But he said, why not go to the QHY 7 or 9 position? What are we using down in Chile?
We have the QHY 7 position, I think. Yeah.
Okay. Has it worked well?
So far, so good. It hasn't failed.
Okay. Are those 2-inch square or
they're 2-inch round?
2-inch round.
Okay.
So
that's a good point. This is 50 millimeters. Well, we haven't bought the filters yet, so we have that option. Yeah.
2-inch is actually 2-inch outside diameter, and it's 48 millimeter thread, right?
Correct. Right. So it vignettes a bit in the corners, but it's not too bad.
Bit in the corners. Yeah, that's
not very much.
Well, that's the problem with the PowerMate. It's 42 millimeters, and so he's vignetting in the corners on that one too.
Yeah, it's just something we have to live with. We don't really yet have the optics to do this perfectly, but it's good enough.
Okay, I suggest that we maybe we can do a little dialogue by email or maybe offline, but they don't want to take over this much of the conversation, so I'll back out. Unless Grady, you have a question? Yeah,
I do. So we're talking now. I understand why we're looking at the 7, the 9, what you've got working down south on the plane wave scope, but now I'm losing lock on the holy grail of filter sets. I've got GRIZ.
No, it's 6. There's 6. There's Y and U too.
That's where I'm getting started.
Oh, okay.
GRIZ, we got Y and U. I had tracks somewhere we were talking luminance, and now we're talking Pro Planet. So if we said the Pro Planet 4 or 742 is the right one?
Yeah, I like that one, that choice the best.
Okay, so in lieu of any particular filter or in addition to GRIZUY?
Well, it's unlikely we'll use Z, the Sloan Z. You don't even have to put it in, but the filter set comes as a set. And it's very low price.
Yeah.
So you're going to get all 6 anyway.
Okay,
So if you've got 9-position filter wheel, you have the 6 Sloans, you have the ProPlanet 742, and you have a Luminance.
okay.
And that's 8 filters, and you've got 9, and you need a dark.
Need a dark, yeah.
So
Dave,
that-
I would even suggest you guys put a pinhole in one of them to look for internal reflections.
Man, right. But if we have 9 positions, we just shoot them all up unless we throw out the Z and put in a pinhole. Yeah.
Or we
Pinholes are-
stay with FLI 10.
Yeah.
Filter wheel.
I mean, why not use it until it fails?
Well, it's just that isn't it, we're gonna have to redo all the spacing in the
Yeah,
equipment.
but
Yeah,
that's
yeah,
rather,
so it would be down for 2 months. You know,
well, no, not if we drive up there.
well, you gotta get the stuff built, right?
True,
Yeah,
I mean, if it-
and stuff delivered. Yeah,
true. You know,
Yeah.
that's a good point. So it's
Yeah.
down for 2 months. Yeah.
So,
So it might be better to put in the QHY 9-position filter wheel right now, and then it's also compatible directly.
I think the 742 ProPlanet filter would probably take the place of the Y and Z both. Because it covers pretty much that range and is putting a lot more light through.
Yeah, you could toss the Y and the Z in favor of the long pass.
is that going to be for photometry, going to be a recognized filter for any photometric measurements?
No,
No,
but-
you have to do a transformation to try
Yeah,
to
yeah.
make it
And
work.
the way you
for-
do that is you take a bunch of Gaia stars and you can find the transformation directly.
But wait a minute. So if we use the 9-position filter, then we can still keep those in there. We're not hurting anything.
Right.
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 So that's would be my argument to avoid that conflict, and we could then have it in the filter wheel and it's just not taking up any particular space.
Sure. You could just, as a matter of usual use, you'd probably prefer the one that puts the most light through, but there might be cases where you'd want to use the Y or the Z. And if there's room in the 9 positions, but
Yeah, the thing where it goes to 10 is what the pinhole, and I don't know exactly what the benefit of the pinhole is. I've never come across that.
Well, the benefit, first off, is the fact that you get a complete image of the optical system. So you can see any internal reflections, you can see strange aberrations, you can see light leaks in your system, all those kinds of things that add noise to your whole process, you can eliminate or at least locate using a pinhole.
Okay, but that's not something
Really?
you have to do daily. So you could use it. We could have the techs up there swap out the filter, one of the filters, and do that. So we could
Yeah,
get by with 9.
I think Tom, it's a very nice idea, but I don't think we'll probably ever use it because we don't do that kind of work, at least not yet. We don't do that type of precision photometry. This is just using CompStar. We don't do absolute photometry,
Right.
which is where it's really valuable.
Yeah, and another reason not to do that is because the more you change something out, have a tech change something in and out, the more chance you got of damaging something.
Okay,
All right,
So
so we're
my-
QHY 9, GRIZ, Luminance, UY, the ProPlanet 742 in a dark. That's 9.
Right. That's
And we're all
not-
giddy up with that. All right, cool.
that works.
all right. Again, I propose we move forward then with the astrometry
All right, second.
topic. Russ, you're always good for an agenda item. I think you're
I
muted.
have a couple of items. The first one is just the possibility, and I want to explore it, of you'll have quite a bit of time on that, and speckle doesn't take much time. So, you can use, do exoplant transits. But the other thing we might consider, and that's maybe really good for student papers and publication, is eclipsing binary, get light curve and do times the minimum. And so if we're interested in doing that there, I'll kind of work with Bob Nelson, and we could get whoever's interested to pursue that over the next few months, and maybe try it out.
I don't, offhand, I don't think there's a problem with it. I would like to do it on either telescope, either that one or Barrow.
That's right.
There's
And the other thing is, I think both for, we got a bunch of telescopes now that we're going to try to automate and remote access and so forth. And we also going up to Mount Wilson this spring, and I'm going to try to set up for this fall, kind of to have camera wheel travel to do a telescope or two, large one in Arizona, like the 2.3 meter Bach. We probably have a night already this spring on the 4.3 meter Discovery telescope, but they already have their speckle instrument, so we don't need that. But anyway, the point is I think we need to work on standardizing, how do we get from make up target lists and things that we can send to our telescopes. And when we get the output, it'll run on Dave's auto STB. So we know what the output has to match the auto STB. And the inputs we've been operating off of GDS.
okay.
Rick has his own, and I'd like to see if we can do the million doubles on DR3. That's another catalog that we haven't tapped yet, and they'll probably be new, when the full DR3 comes out with and identifies a bunch of binaries. We're going to have another data source. But anyway, we need to think that through, and we'll probably have to iterate it over time, but there ought to be some working group, maybe the folks going to Mount Wilson for the engineering checkout. And but we need to think through this problem, or we'll be going in multiple directions.
Yeah, and I
Scott?
think we need to get, we want to, and it seems to be hard to do, but we need to have several trained operators so that people, not that they have to attend it all night, but so that these scopes can be used routinely regardless of individual schedules.
I've been pretty lazy on getting started with that.
Well, hopefully the operator will only have to know how to turn on the telescope and start the program, and in the morning distribute the results, and that's the whole task. Or in the morning, just alert people that they've got data is better, and they can log on and get it.
Right.
So
on that note, since yesterday, live view is now working again in Nina. Very quickly, but images aren't being saved yet. So no guarantee if that'll happen quickly, but there's already progress. So
okay, yeah, we've been working on automation. Really, not me, but Leon and Nick have been working on automation and through Nina, which I like a lot. But if we can't get it to work, we need to have a backup. We'll get something to work that'll be fully automated. So we have to plan for that, and we have to plan for a lot of data, and the individual observers are going to have to take that data and take the bispectrum results and do the final, phase reduction and phase reconstruction, which is really quite simple. I think. So,
It raises a question again when you bring this up that we're banking on the QHY 600 and designing the system, the optical train for that. But is there a chance we're going to move? You think we're going to go decide not to use that because of Nina?
well, we're going to have a conversation with Dan Gray today and see where he's at. So I want to make sure I have a clear backup path if we need it. He has the SDK, I believe. Yeah, he told me he actually told me in an email that he had made a lot of progress on it. So anyway, we'll find out where he's at. QHY cameras are becoming very popular. So it's something that is going to happen. I think Dan is going to have to make it happen because he works with the University of Arizona.
He does use the video mode as well, right? Do you know?
He uses. Well, I'm gonna find out. I know he uses the video mode in the ZWO.
Okay.
I'm gonna find out where he's at with that interface using their drivers. And so we'll report on that next week. I have STB working automatically in a sense. Let me share my screen, Pat.
Oh, I'm sorry. Yeah.
I'll show you that really briefly. There's really all you have to know is that it's automatic. Okay, so if I bring up this window, what I can do here is I can select a top level folder under which all of the observations for that night have been placed. And the structure of that directory tree starts at the top level folder, and the first level down from that is the users. So there'll be, say, 2 users, user number 1 and user number 2 that evening. Okay, so we go and we find that top level folder. I've already got it here. Okay, and in that folder, there's 2 users. You can kind of ignore this, but what it says here is there's 2 subdirectories. There's 2 user subdirectories. There's a total of 4 directories with images. I just cooked this up as an example. And there's only 374 FITS files, so it wasn't a very good night, but nonetheless, we'll reduce it. So you can choose the size of the cropping or padding. What we'll do is we'll center the image using the brightest star in the image. We'll save the FITS cubes because we might want to use them again, and we'll display the images as they're being processed. Okay, so let me arrange this so that you can see it. That should do it. So here it's creating FITS cubes. Then it does the bispect, it goes folder by folder where it found images. It's processing the FITS cubes. Then into the bispectrum results, and it goes on. Okay, it just does the job.
We're going to center the target star in with the automated scope software. What happens in the case where there's a brighter star in the field than the target? Do you have can you add the ability to select?
You don't click this, and you just don't click this. No, I have.
Oh, okay.
The moment I can't know which star from looking at a small field of view. I can't know which star you want. So, as long as the scope is tracking well, you don't have to center the. You don't have to click this checkbox because you can just leave it unclicked, and we can watch what happens. Let's cancel that and do this again. So there it is. It's not centered, right?
Okay. So, but if there's a competing star or several stars perhaps in the field, then it'll process those.
Well, it's almost never true that you'll have a second brighter star in the field of view. And if you do, well, you're just unlucky.
Okay, got it.
At the moment, there's nothing I can do about that because this is fully automated processing. We don't want an operator to, intervene and click on a on the star that you're interested in. So I can't
Gotcha.
solve that problem.
Okay,
Dave,
if you-
as long as
that's
both-
just a bad collection.
as long as both stars are in the field consistently, it'll show the whole field, won't it, as a result of bispectrum, including
Yeah,
the double
yeah.
and its companion.
absolutely
Right.
true.
And then you could choose the ROI to be 128 by 128 to get it out of the field of view. If you realize.
Yeah, let's do that. So you'll
Yeah.
see what happens. So here I'm not centering the star, right? And you can see it's kind of on the edge of the field of view, which might be a problem because we want all of the information. And if I click that, then it will center it, which is far better. Okay.
It goes a lot faster
Yeah,
with smaller
Well-
file output.
But we have plenty of hours of time to process the images, so I'm not worried about that either. It turns out that I can process the images about as fast as you can take them. So if you have 6 hours worth of imaging, then it'll take something like 6 hours to process all of the bispectrum files, plus or minus, within a factor of 2. So plenty fast enough. And then what happens is you get some results. So again, let me cancel this because we don't want to be bored with that. Let's go to find those things. So there they are. So we have user 1 and user 2. So underneath these folders is this is the folder full of FITS files for the reference. And here are all of the bispectrum results for all of the folders under user 1 will appear here, which is the logical way to do it. So you'll have to look at the name to figure out what you want, but presumably when we create the directory tree structure, we'll have, target and filter and exposure time. It'll all be placed in the name. The name will have a bunch of we'll have all of the folder information from whence it came, right? So that's how it'll work. I don't have an example of that yet. I would love to have a real example, but I may have to cook up an example based on the conversations we've had about how to organize the directory tree. And so you get the idea. We'll make it work. It'll be completely automated. So if we can automate the telescope, then we can automate the reduction of the, at least this part, which is the long part, making the bispectrum files. Okay. So we should have,
Leon,
the next, after you make the BSP1 file or whatever it is, the next step is human in the loop, right? So if we really get to the point where we're digesting a large number of observations in a night, then the human in the loop is going to be the bottleneck, right?
I mean, that's
A
the way
high-class problem.
That's the hot, right. We've reduced the problem to its essential elements, I can't remove the human from that really. It takes so little time to go find the file. You got to go find the file. You've got to load it in. You'll already have all of the information there about the removing photon noise, photon bias noise. That'll all be there. You've just got to pick a filter and you've got to make the measurement. And, if the human isn't willing to do that, then we probably should be digging dishes or doing something else.
Just a comment, Dave, on when we were reducing the kit peak data, you had a semi-automatic thing. Remember, it would run automatically and then display the things, and you could either accept it or reject it. So, so it had a forecast, position, angle, and separation, which helped but if it was possible to have I can remember, you could run through really quickly. You just click and look at the next one and either accept it, or if it didn't look right, because, the semi-automatic thing couldn't quite do it, then you'd go in and change the apertures or whatever it took to make it right. That would help a lot and could probably reduce error rates.
Yeah, absolutely. I agree. In this case, Russ, we did that because we had, two peaks to worry about. We had the two sidebands, and we didn't know which one, and that was a complication. Here with bispectrum, we'll know, though there won't be a sideband. However,
Yeah.
I think trying to do the fully automatic reduction, including the measurement, is something really fun to do and will save a lot of work. And I'm going to work on that part of it.
Yeah, and if we could make it semi-automatic where it at least loads the stuff up for you and sets up the results file, sets that all up for you, and then the human does the final steps.
Yeah.
That
And I'm
might
waiting
make it easier.
Yeah, so I'm waiting to have an actual working example from a telescope with this directory tree structure, because there's kind of a complication involved here because we have reference stars. So I need to have a decent example, and then I'll try to figure out how to do that. And I don't think it's difficult at all, to tell you the truth.
That'll be cool.
Dave, if it would help, I could load an example observation up on the cloud and send you a link and see whether it's already in the right format or easily changed to fit the format you want.
Well, yeah, I already have that. I have plenty of examples. What I don't
Okay.
have is an example of this automated observation with the particular tree structure we're going to use and so forth. A lot of
Real
it's just
automated
loading the right files and stuff, right?
Yeah.
I can take a few files for you, which create the tree structure and then just replace them with some old ones.
Great. That's what I need, Leon.
Okay, I'll do that today, tomorrow.
A quick note, and that is that Scott came up with a kind of a workaround for the Excel's problem on putting dates in for RA and DEC, and he sent it around. So if we're coming up with our target list, we can come off of GDS with a full CSV file, run Scott's little fix, and that'll should take care of things, right, Scott?
Yeah, it's just a matter of finding the right format in Excel. And when you do, it converts, it displays it properly.
One thing I wanted to talk about or discuss is the proper method for finding reference stars, because, I have the SAO catalog, I can read it, but I don't know where to put it exactly, what to do with it. So how do you plan on using the tools to generate reference stars?
So far, Nick already looked for reference stars. He did show you the script, right?
Mm-hmm.
Yeah. The
Well,
query.
yeah. I mean, this is the discussion that Russ wants to have, is how you pick targets and how you pick the associated reference stars. So it's a very important topic. And I'm not going to get involved in it at all. I'm going to try to, we have three plane wave telescopes that we're going to try we're going to, use, not try, but we are absolutely going to use them, and they're going to be automated in some fashion or another. So you've got to be prepared to pick targets and reference stars to get them into whatever format you want to use them in, CSV files, or I suppose is the obvious way to do it, and load them into some tool, whether it be Nina or Dan Gray's tool or some, tool that we don't have yet, and to run an automated night. I mean, now the work is to fill the time of the telescope.
So it says your internet connection is unstable, in case I cut off. So there are two options which we have considered now. One is pre-selecting reference stars. I talked about that last week, and inserting them into the rows between the targets. And the other thing which Nick now did, which is faster, is he queries Simbad from Nina every time he needs a reference star. And now the only question there is, Russ, what are the constraints? I mean, the magnitude should be similar, brighter or similar.
Right.
Up
I mean, it should be
until,
as bright. You want,
yeah, but
you want to have a, yeah, sorry.
what's the tolerance there? Do you go 4 magnitudes brighter? Is there, or until it's clipped off? And the other question is star color. Where do you want to stop?
Well, one of the recommendations that we, approaches we might consider is to pick nearby SAO stars. I think we've talked about what, between 8th and 10th magnitude, or 7th and 9th, or something sort. So no matter how bright or faint the other star is, this would always give us a good signal to noise on the reference star. And the SAO stars, we can tell whether they're double or not. And so, and Dave has already set up a routine to automatically grab those. So I would kind of vote for using Dave's routine and SAO stars.
But within SAO stars, I think is the question, if you have multiple SAOs, is it the closest one, or is it within 7 to 9 magnitude closest? What's the criteria for the software?
I think it's, first off, it'd be between 7 and 9, and then after that, it's closest. And I think David said that spectral type isn't really a big consideration.
What about the color? What's the tolerance?
Speak, Dave.
Well, yeah, so these are questions that we haven't answered yet because we haven't explored them, right? So here's the considerations. If you use a vastly different spectral type, suppose you're doing red dwarfs, but you pick a 0 star as your reference, then the diffraction pattern is going to be a bit different. It's going to, the diffraction pattern is obviously part of the problem because I'm using it as a deconvolution star. So you'll get artifacts in the diffraction pattern of the deconvolved star if the spectrum is very different. And I've actually seen that. But it still gives you exactly the right photometry and separation. It's not like, you're doing something terrible. The image isn't quite right because the diffraction pattern isn't correctly deconvolved. Nonetheless, you make exactly the same measurement. Okay. Get the idea? The measurements are going to turn out to be perfectly fine. So that's why I say that the spectrum isn't really super important. Now, if the separation gets to the point where the secondary is within the diffraction pattern of the primary, now strange things start to happen, but you probably shouldn't be there anyway, making, scientific measurements. If you get the companion within the first diffraction ring of the primary, it's not going to work anymore.
Yeah.
To combat that, we are going to, we plan to create one list. So let's say one list for La Serena, and then within Nina specify what telescope it is, how far you want to go. So you can just throw the same list into the 1 meter and the 24, and it will decide itself what the minimum separation is, which it should allow, and then base priority upon that.
Okay.
Yeah, well, that's great. You've also got the problem, if we do normal quote doubles, then you might have a A0 primary and I don't know, K secondary. And so you can't match the diffraction pattern anyway. Right. So, there's lots of stuff to think about, and some experimentation would be useful here, but you've got to design the experiment because there's so many variables that if you don't carefully design the experiment, you'll get completely lost in all of the different possibilities. Okay.
So if I understand it, we're seventh and ninth magnitude SAO star, the closest, but not too close, with a minimum separation defined by telescope. Is that
I don't know
right?
what that
I would
means at all.
What's
I
that?
would suggest that rather than using seventh to ninth magnitude as a boundary, just say it, up to 2 or 3 magnitudes brighter than the target star. Because there are some, down to maybe 10th magnitude SAOs that might be perfectly fine for a faint double.
Yeah, 7th to 10th would be okay. The issue there is the signal to noise ratio of the comparison star, the reference star.
Well, you don't want it too
So-
faint.
Right. You don't want it
want
too
it brighter.
faint. Right.
But as long as it's brighter by a magnitude, it should have better signal and noise and be okay.
Absolutely. In fact, you can go to 7th magnitude and you have to adjust the exposure time down to, a few milliseconds at 7th mag for a big telescope. Or you'll saturate. Saturation is more important than, it's a very important consideration that you always have to get the right exposure time to not be past about half full well.
What I was trying to say, I guess, put it a different way, make it a difference in magnitude between the target and the reference rather than an absolute boundary on the reference.
That doesn't work either, Rick, because suppose you're doing a 15th magnitude star, you don't want to use a 12th magnitude reference. You want to use a 10th, 9th, or 10th magnitude reference.
Are we going to do 15th magnitude?
Oh, yeah. I mean, on GBO, I was doing 14.5 mag primaries without any problem. In fact, they were doing quite well.
And that's where the fun science can be.
Yeah.
Was that a 17-inch?
GBO is the
Seven.
CDK 700.
Uh-huh.
So to 20, what's that, 28?
28. Yeah.
And we'll have a 1 meter. So we could probably do, according to my spreadsheet, we should be able to do 15.5 mag primaries and have enough SNR.
Well, that'll be a variable we could fool with, can't we? I mean, there's no point in putting it down exactly at this point,
Right.
the magnitude of the cop star.
Well, if you're going to automate this or head towards automation, you need an algorithm that automatically will select the reference star for you. And, saying that it has to be an SAO star between this magnitude and this magnitude to give you the signal noise you want. And not a double star, that might be enough to give us what we need. And it's nice and simple for Leon to implement.
Yeah, so that's why I recommended originally 8 to 10th mag. It always worked well for me.
Seems like that's real KISS.
Yeah.
That's a real time saver to be able to have the software do the reference star selection.
Yeah.
Oh, please.
Huge.
We don't want students to picking bad reference stars.
The thing is with that criteria, it's already done. Like selecting an SAO star 8 to 10th mag is a short query, and that's in the software already.
Certainly a good place to start.
Yeah.
Yeah, so if you want to narrow down the spectral type, there are a lot of SAO stars often within a degree or two of your target. So if you want to narrow it down further, then you'd base it on closest match to the spectral type.
Can you substitute temperature for that? Simply,
Sure.
yeah, that would be easier to deal with quantitatively.
Mhm.
Yeah.
Well, I think you can just run an experiment on that, right? Just select the same target, different nights, always in the same position, and then go to SAO stars of different temperature, and then see what the difference is.
Right. So
What do they have in the SAO catalog? Do they have spectral type or temperature or both?
spectral type.
Okay.
But it's pretty easy to convert spectral type to temperature, it turns out. I mean, there are probably algorithms on the web,
Yeah,
but I did it too. I think I have the algorithm somewhere that I used. So what was I going to say? Disappeared. Oh yeah, about spectral type. There's one other factor. If you're very far from the zenith, then atmospheric diffraction, differential atmospheric refraction will change a bit based on spectral type or temperature, right? And that turns out to be a fairly important effect. And I have seen it. You don't get a perfect deconvolution if the color, if the temperatures are vastly different. So that may be the most important of all considerations.
And it's
So
more-
far,
Is that-
sorry, go ahead.
Is that, Dave, is that the same as the atmospheric dispersion?
Yeah, it's
You get
atmospheric.
Yeah, you get the shape changing into a elongated smear instead of a round star.
And
Right.
that's more important as you get larger and larger telescopes, you're able to go to closer and closer stars. So wide stars on small telescopes, it's not a big deal, but you get a 1 meter telescope with this star is a tenth of a arc second apart, then that could be real trouble.
It
And it
is.
depends
That's a-
pretty dramatically on zenith angle, I think.
It does, very dramatically, right?
So
So what I found is that, you can make it a significant improvement if you're way down, only 30 or 40 degrees elevation. If you have a better match in color temperature, in temperature, color.
Yeah, so far I ignored that variable. I mean, it's one of the most important for exoplanets, but you mentioned here for a speckle to just choose a region of the sky near the zenith and let it run. So as far as I know, we aren't even considering anything further away from the zenith, right?
Well, we have to be away from the zenith, of course, because you'll only have one, there's only one tiny band.
Yeah, I mean, yeah, but
Yeah.
let's say lower, we won't be lower than 60 degrees in altitude.
Well, if we
That's all.
use both the northern and southern hemisphere, we can limit our range to 45 degrees or higher for every telescope, which is kind of nice, right?
Okay, but at 45 degrees, we already have to consider a color more, right?
Well, you can work it out. It's not hard to work out what the spot would look like with the elongation of the spot is if you go from red to blue, the difference is, it's around a tenth of an arc second, as Russ said. So that's what you're looking at. And when you go to a 1 meter telescope, you will be able to see it. I could see it on GBO. I could see the difference in elongation at 40 degrees elevation.
that's another reason that filters are good, because they restrict the wavelength distribution, so you get less of that dispersion.
Right.
Yeah, and we might just avoid looking at, it's going to be rare that we're looking at really blue stars. So we might pick a spectral type that's, K or later, something like that, or G or later, and avoid real early things. They're rare anyway.
Well, that's
An
a way to handle
example-
the,
So go ahead, Dave.
yeah, that's the way to handle the pick the reference star problem is it has to be G or late, G something or later, right? Kind of right in the middle of the main sequence.
An example of dispersion problem, I think, popped up with some of Ivan and Sophia's class from last summer. The first, I don't know if that was the first ARE, the experience or what, but
It was.
one of their stars was about 0.7 arc second separation, and it should have been easily resolved with Barrow, but it was at 13 degrees south, and I think they observed it probably off the meridian a ways, and there would the star was dramatically smeared, and happened to be in the direction of the position angle. And so there was no secondary star there. It was just blended into the smear.
It was
So they
probably an
couldn't
unfiltered exposure.
No, it was, well,
It was
I don't remember
filtered.
the filter. No,
It
it
was
was
filtered.
R. It was the R filter.
Hmm,
It just
I've
happened
never
to be
seen that.
smeared.
I've never seen that in R. R is well, you can look up the differential refraction in across the R band, and it's not very much.
But
I
at
think maybe
13,
they trailed it, they followed it till, at the wrong time of the evening, and it was a little bit too low.
Well, yeah,
Jack,
if it's really low. Yeah,
if it's a -13 deck, you're below 30 degrees altitude, I think. You're
that's
right.
bad.
Yeah, so you're in trouble anyway.
Yeah.
Barrow can go down to 0 south, and so it's easy to make that mistake.
But David, you made a good point that, this atmospheric dispersion is much worse as the wavelengths get shorter. So it's can be pretty bad in V. And as you get, if you get down to R, then it's not so bad and so forth. So it's not as big a problem for our red dwarf research.
It's actually not really a big problem if you stay above 40 degrees, 35, 40 degrees elevation, and you don't pick a blue reference star. My mistake was I picked a very like a A0 reference, not quite, A0 reference star, I think, something like that. And actually the reference star had the elongation. And when you deconvolve that, you get in the other direction. It was a mess, but you get the idea. Yeah.
I'm happy to hear these numbers because like 2 or 3 years ago at this point, I did my own rudimentary experiment with a SCT back then at looking at planets and the elongation there as they have different altitudes.
Mhm.
And my answer there was that I shouldn't go below 38 degrees. So it's perfectly in.
Yep, that's exactly it. Anything below 35 and you're in big, you got to know exactly what you're doing. So if we stay above 38, you'll be pretty much okay.
Question, how are you going to handle any kind of flares that happen on those active red stars which you got?
Flares.
Yeah, they're pretty prevalent.
Now we're
That's
talking
good. It
about,
just makes them brighter.
Doesn't that kind
Turns
of
them
throw off
blue,
your
too.
differential magnet?
Yeah, it makes them blue.
yeah, I don't have an anti-flare filter yet figured out.
Tom had asked in the chat whether Nina had an API, and there's people working on it around the world. It's open source. And so, yeah, if you're planning on writing something, you can jump on that team.
Just a casual conversation there. I just want to find out a little bit more about it. So, but I'll look it over. I'll take a look at Nina.
What's in it so far is pretty darn good.
Okay, well,
You got
Matt,
Anything else? I think we've,
Matt is going down to Chile, probably in February. So hopefully he'll have the speckle machine running. And it looks like we're committed to the QHY cameras for other marketing reasons too. So we have to make it work.
oh, okay. So that's good for us to know that we're not throwing that into the hopper is another question to deal with.
Yeah, it doesn't look like that's going to work for
Okay.
plane wave anyway. So
Yeah. And Rick, that it's really definitely want to see that 2.5x because there's going to be some weight hanging off of that. We've got to be sure it's going to be, need to be able to trust that it's going to be able to fit well with other adapters.
Yeah, it's a pretty husky chunk of aluminum that's the housing for it. It's probably about a pound altogether.
Okay.
yeah, and we'll get one ordered. If you give me the information, I'll get one ordered as a replacement. But it'd be great if you could send that to Pat.
Yeah, copy Dave and Grady.
I don't think I need a replacement because I'm not going to go to the 22-inch anymore if if remote works. It's a lot easier, a lot more productive.
Right.
One of the kind of plan B reasons I got it was in case of this Russ's idea of have Speckle will travel to other larger telescopes, but I don't think there's any big telescopes that are ever going to need a Barlow. They probably all have some configuration that can work for Speckle already, or at least maybe with a more normal 2X Barlow. For example, the Mount Wilson 60-inch is already f16. We don't need anything because that's just about right for this camera. So it doesn't need a Barlow, and I can't imagine any other bigger telescope than that would need one.
Okay.
At least not 2.5X.
About that, I was thinking the entire time, how viable is having an instrument switcher? So like a mirror which goes between instruments, because Dave, you said with many diagonals, you measured 1 to 2 waves error, but and of course you have the problem of the camera then hitting the bottom of the mount. But I mean, in the plane wave 1 meter, you have a tertiary mirror, so that must work out. Is there anything, is it a viable option? Like at the end of a normal CDK, is there anything to put there to switch between two different cameras?
Okay, so the Bader optical switch is, I trust those guys. I've never measured it. Now, talking about diagonal, does anybody remember RTMC? Anybody go to RTMC? Tom, of course, Scott, Russ, Rick, almost everybody went to RTMC. So in 2004, do you remember a talk I gave with Peter Saravolo on bath interferometers? Anybody attend that? No, nobody was there. So Peter Saravolo is another, he's a Canadian, fairly famous optician. So we had this little demonstration and we measured some Barlows directly using interferometry, and they all sucked. I mean, I can't report the results anymore, but they were almost, the best one was like almost a wave of astigmatism. So, you have to be careful with those damn things. They're not very good.
I've got to run. I've got a 10 o'clock Zoom so I got to bow out, but good session. Thanks.
Take care.
Bye, Russ.
Yep.
Yeah, so to answer your question, I don't know. I mean, every individual manufacturer will do a different, better or worse job at it, but then you've got to mount it. So if it's not blah, blah, blah. So,
well, we've got a 4-position instrument rotator from Optech on ours. So
yeah, and I used that at GBO and I found it to be excellent. So, when you actually make an instrument to do that and not just a cheap diagonal that costs a couple of hundred, $100 or something, probably isn't going to be well controlled optically.
yeah, and you saw, well, you looked at some of the images and that were getting off the Barrow 17 and they were good.
They're excellent. Yeah.
Yeah, and that's, they're going through that Optech Perseus. Well, I don't know if there's a 2-position equivalent.
How much do they cost? Because I mean, not anytime soon, but I mean, in years, I'm going to definitely change out my mount.
The Optech
that becomes a
Perseus
viable
costs,
option.
the Optech costs about $4,000.
Yeah.
And the Bader is more expensive than that. I don't remember 5,000 or 6,000, but it's really quite an interesting instrument, and it's really a good instrument.
Okay. Yeah, having instrument rotators handy. I don't know. This thing that appeals to me is if we can get a 2.5X Barlow, then it's got enough field of view. It's going to be useful for photometry, exoplanets, and it's also going to work perfectly for speckle. So I hate to complicate things by putting a Perseus on there.
Yeah, and there's not a lot of back focus on a CDK 17 anyway, so there's other issues to contend
Yeah,
with.
we've with ours in there, I think we've got a total focus range of less than a half an inch, so it's
Not much.
not much. Yeah. Okay.
Okay, well, that's all I had.
Pat, without the optical switch, how much back focus does that take up? For the SRO, it'll be shorter, right? Because you won't have that.
Yeah, I honestly can't tell you. I've got to dig it up. I don't remember.
We'll
Yeah.
have plenty of back focus. We'll have to add spacers, to
Yeah.
get the focal plane in the right place.
Right, and that's
You won't have any trouble.
that's the issue. And then I think we can we can either compensate and move the scope, forward on the mount to get enough swing through. This is what
By
I'm,
adding weight.
yeah,
which-
adding weight. Yeah. Yeah. And it's not going to be overloaded for weight, so shouldn't be a problem.
You're on a 500 mount, which is a pretty beefy thing. So.
Yeah. Yeah. Okay, well, very helpful discussion for me and Grady, I'll tell you. This is good. And we'll I'm looking forward to it. We'll get it. I think we're probably going to take a deep breath when settling in on the equipment, but I guess we'll probably stick with the FLI. But I want to check out. Well, no, I think maybe I really should check the QHY filter wheel. We should really do that.
Well, I can say I have the 5-slot 2-inch QHY filter wheel, and it has been working without a problem.
This is a QHY?
Yeah, so you're thinking of getting the 7-slot one. I have the
I
5
think the 9
the
slot.
9. Okay, that's the XL version. Yeah, but
Is it-
driver's the same, and it has never been a problem.
And it interfaces with Nino, okay. This ASCOM, yeah. Okay. All right. And then if we go that, we may go to round filters. So there's a few things to sort through.
Yeah.
All right.
Well, a 50mm round filter worked with my QHY 600.
Yeah.
Fine.
The FLI filter wheel requires squares at 50mm, which are more expensive. So there's a
Yeah.
advantage.
Speaking of which, how much are those filters? Since you mentioned they were relatively cheap. I don't know.
Well, the squares were like 1900 for a set of 6.
Mm.
The
Wow.
whole range, and I believe the rounds are like 1400.
Mhm.
I paid 500 for a single round.
Yeah, I know. That's
Yeah.
why it's really it's a
Yeah,
hell of a deal
Botter-
you don't want to miss.
Botter is a really old and great company. They're trying very hard. They've got a filter manufacturing company that they work with, and they own part of it, I think. So they're trying very hard. Chroma, is really kind of way overpriced at the moment. So they're trying to sneak whenever you overprice something, somebody will sneak in, underneath you.
Yeah. Well, it's good to see that there's at least some options there, because there for a while it was not looking good on filters.
Right.
Jeez, it's like everybody's out of business.
It's like when a government authorizes a monopoly, you're totally screwed at that.
Yeah,
point.
exactly. Now we have competition at least. That's
One more thing, if you use the QHY filter wheel, what's very nice is you'll use their custom interface. So they don't have a threading interface between spacers and the filter wheel. You actually place, I think, 9 screws, like I forgot, I should know, but anyways, lots of screws, so you get far less flexure according to them.
Oh, no, that's good to hear. I like
Well, Dave
that.
can probably say how much of a difference that makes across the entire imaging train, but
Yeah. it can
according
make
to
a
them,
huge-
it's substantial.
It can make depends on what you're hanging on it, but flexure is always bad for both
Right.
collimation accuracy and focal plane tilt.
Yeah.
So that's why we invented, the secure fit system at PlaneWave, is because you don't want any motion if you can avoid it.
Right. Yeah. Yeah, I'm surprised. In the ZWO 1600, they have a single screw. It's-
Yeah.
Yeah, somebody who doesn't know what they're doing.
it's just,
Or even worse, really, really small threads on some spacers. I looked at that as well, and that just doesn't work.
Yeah.
Big camera hanging on the back.
yeah, exactly. I like that. That's good to know, Leon, that that makes me more comfortable with making that change.
Yeah.
Okay.
But depending on how many spacers you'll add, it'll be really difficult to get the right screw size.
Yeah.
Sorry, screw length, not size.
Okay. All right. This is getting more challenging. Okay. Thank goodness for Eric Blackwell.
Yeah, he's a great guy.
He is a great guy. Yeah. We enjoyed him when he put in our system at Barrow, and we've developed a pretty good friendship. We're sorry to see him move to Michigan, but
Yeah, well,
yeah.
me too.
Yeah. All right. Anything else, guys? No? Okay.
All right.
Till
fun
next
meeting
week.
Again.
Thanks.
Yeah,
Good.
see you next week.
Take
Yeah.
care.
Hey, Scott, stay on for a second.
Okay, I will.
I hope I had confused the heck out of everybody on the 808 or 80606. You were sending out the files by the Dropbox link. I'm just saying to do their results, put them back into that Google shared.
Oh, so the share file that you set out for all four of us contained those three.
I just thought it'd be
PDFs
good in
or whatever.
reference because we're going to end up sharing that file with Kyle up at,
Okay,
and then,
so I will send out from the other folder, I will send out links to the specific data.
right,
In that folder, I will attach the names that I'm sending them to. And then when they get their results, I put them back in that folder.
put them into the Google Drive folder. I just didn't want to screw around that much with everybody playing around, giving edit permission in Dropbox and all
Yeah,
that.
yeah, okay. So that's fine. I will do that because Jerry had a question on it. He may
Yeah.
have sent a copy
Yeah,
to you on it. too.
I responded right before this meeting, but it may not have been clear. But I just didn't want to give
Okay.
up.
So my job, the things I can do right now is send send links to the files,
Right,
the data files.
right.
And also, I guess I got your email on the other collections that are in the other folder.
Yeah, free folder.
And all I'm going to do with those is just send to the group, which is, I think the group consists mostly of the people who attended your class, right?
Yeah, they're almost entirely that. I can send you I'll send you a spreadsheet of the people I've been sending stuff to. Many of them, I don't know, hopefully I don't expect them to participate. They've just moved on, but I can give you give you that list that you can easily send an email to.
Okay,
Okay.
yeah, why don't you do that, and then I'll send out something and invite them to receive data from one of our collects, and
Right.
if they respond and they want to do it, then I'll send them the data.
Yeah.
Or
Yeah.
links to the data.
Links to the data with the, that'd be ideal. Yeah.
Okay,
And that should work. But I'm not going to use the Google. I don't want to bother with the Google thing.
yeah, on those individuals.
On this 606, yeah, that just unique.
Oh, I see what you're saying.
That's unique. I just want to share that easy to share it with Kyle and Exoplanet Watch without getting tangled up with editing permissions and this, that, and the other thing. Because I gave everybody editing permissions in that folder.
In the folder that just had the 3 files.
Yeah, I just put those 3 files in there. We had them in Dropbox. So I thought, well, it'd be used to have in there too, because we're going to share that whole folder with.
Oh, the other thing that Jerry asks is he went to your site to get the documentation from the course.
Oh.
And he said that the site had changed substantially and he didn't seem to be able to find the course information that that was there before.
Hmm.
And I don't know, I'm not familiar with, is that in?
He took the course in, well, I'll just go to him directly. I don't know what that would be.
Yeah, I certainly didn't. I don't know, I wasn't in the course, so
Yeah.
I don't know what was in there, but he was looking for more information on running
Exotic.
yeah.
Yeah.
And he looked there and didn't find what he expected, so.
Yeah, I'll just call him and see if I got it straight, because he should have it there, because it was a class, it's in a Google Classroom. And if he's using a Google Classroom, you can get to all the, it's still up, still available. I'll just call him and find out.
All right.
Okay, so I'm going to send the spreadsheet, send the emails. Okay. Make sure I've got it straight here. Send the emails to you. Oh, that's the other thing I was going to say. I sent you a note too that Mike Jason on the Slack had said that he was interested.
Yeah,
He would do reductions in exotic.
Right. So I should quiz him and see,
Yeah.
First of all, if he wants to work on the 8086 stuff.
Yeah.
And then if he wants to do some other ones too.
Yeah.
I'll send
I just
him.
didn't want to load up Jerry too much, and there's so many of those little LCO ones. I was thinking, well, great, have him pick up so that Jerry's got 3 LCOs and then give the rest of the LCOs to Mike, and
right.
Yeah, and just with the forewarning that they'll probably be flat lines.
Yeah, right. Very uninteresting to us.
Very uninteresting, but it'll be good practice for you.
Yeah, right. They'll know how to run exotic and
exactly
submit.
Right.
Okay.
All
right. Well, I will get a hold of Mike on that.
That'll save you from having to get involved in it, because you've got enough things to do.
Yeah, I find that I am well occupied lately. Okay.
Right. Enjoy retirement, huh?
Yeah, exactly. Well, it's fun, and it keeps me out of the bars. So.
Exactly. All right. All right.
Okay. So we'll talk again.
Good.
We'll get busy.
Good. All right. If not, I'll see you tomorrow night. Okay.
Oh yeah, Saturday night. Right.
Yeah.
Yeah, I think that. Right. So we'll try to do an exo tomorrow night.
Yeah. Great. Thank you.
Okay.
Bye.